Okay, so this is the last standard lecture for CET497 Capstone 1. We do have an audience participation thing next week with Professor Braverman's 498 class. They're going to be doing their final presentations on Friday next week. I hope everybody can make it. I will be recording it, and so I would like everybody to give some feedback on the different presentations, but I'll make that available in Blackboard so you can see what I'm asking. It's basically going to be like the rubric that I use, but I'll get you to check some boxes on it for each of the... I think there are 3 presentations, I'm not sure. I'll have to check with Professor Braverman. Okay, so it's pretty much all orange, and I don't have much to do today except heckle, so because you're going to be doing most of the presentation today. That's where we are. The aim is to finish the semester with those 2 deliverables, the preliminary design document and the presentation. I think I said last week, after I gave feedback on your draft preliminary design documents, that I'm not expecting those documents to be done until after this presentation. And I've just set up in Blackboard 2 things. I've set up a presentation, so the thing we're doing today, with the rubric in there, and once we're done with the presentations today, I would like you to upload your slide decks, or a link to your slide decks, into Blackboard once we're done. I'll give you some feedback at the end of each presentation, and the document I've set to be due by Friday next week. If you want to submit it early and get feedback on its current state, that's okay. I've set it up so that you can have as many resubmissions as you want. Not that I'm going to be able to deal with as many as maybe you want, but I'll deal with as many as I can. So please take advantage of that, so that by the time Friday next week comes around, you've got everything, all your I's dotted and T's crossed. Okay, so that's where we are, and the preliminary design document and the review, or the presentation today, is worth about half the grade for the course. I'm pretty happy with what I saw last week in the drafts, even though I gave a lot of feedback. I was pretty happy with the state the draft preliminary design documents were in. So hopefully my feedback and the intervening time has given you time to do even better. So we'll see. So I have a list. It's the same list as I've had before, but I don't know whether anybody wants to volunteer to go first. Any of the teams? Otherwise I'll just go.
Smart Fridge will go.
Smart Fridge? Okay.
Yeah.
We can do that. So that was the, let's go with Smart Fridge first. And let me just write, if I can get it to write, there we go. And parking and security can fight it out.
We're next.
Yeah, we could be second. Security.
Security second. Okay. Sounds good. And parking got trampled in the rush. That's okay. That's okay. They've all got to be done in some order. So, yeah, if you want to, I'll stop sharing my screen, and if you want to start sharing yours, and we can you can kick it off, the Smart Fridge Update team. Excuse me. So there's Eric. Let me just see if I can figure out where the stream is. There it is. My problem now is, there we go.
You all set?
Just let me get it on the screen that I'm recording.
No problem.
It's being a little painful for some reason. There we go. And let me just make that full screen. So go ahead.
All right. Good morning, everybody. My name is Anthony Wismechi, and welcome to our presentation for our project, the Smart Fridge Upgrade. Presenting with me is Michael Puaka and Eric Bernstein. And we'll be talking about our Smart Fridge Upgrade. We believe our device can fill a void in the market, as we don't have a genuine direct competitor. Even though the technology has been around for about 10 plus years, allowing you to shop with peace of mind, there are no commercial options that are actually known to us like our product. Everything we've come across so far was a DIY project or a new lavish fridge. This can lead to making a perfectly good fridge obsolete. We plan to make ours more accessible, as it's an upgrade feature, not a complete new fridge. Next slide. So our key objectives. For our functional requirements, the system shall keep an inventory of food. The system shall have 2 cameras, which allow for pictures being taken of fridge inventory. The system shall have a connection to a secure network. The Smart Fridge Upgrade shall have the ability to scan produce bars for inventory. The system shall send reminders on when certain produce is going to expire. And for our non-functional requirements, the system shall be able to run off a rechargeable battery. It shall be able to withstand refrigerator temperatures. The system shall at least last 12 hours on one charge. And the system cameras shall take pictures of the inventory when refrigerator is open. And the system shall automatically send alerts on food recalls for expiration dates.
Alright, so the purpose of our system is to provide a real-time inventory database of the consumer's refrigerator, which can then be viewed through a mobile app. In order to do this, our system will contain cameras, a database, a barcode scanner, its circuit components, and a mobile app. So 2 cameras will take a picture of the contents inside the refrigerator every time the door is opened. The camera will be triggered by a photoresistor due to the light coming into the refrigerator once the door is opened. The camera will be set on a 5-second timer, where as the timer ends, a picture will be taken. Once the pictures are taken, they will be sent to a purchase domain through GoDaddy.com. The pictures will be sent wirelessly through a wireless network adapter made for the Raspberry Pi. The database stored in the domain will consist of the 3 most recent pictures taken from inside the fridge. The database will be configured to delete the oldest pictures once a new one is taken. A barcode scanner will be installed on the outside of the refrigerator. From here, the consumer can scan their inventory as they fill up their fridge. This inventory will be available through our mobile app. This way, the user can have a pictured inventory and a written inventory. As the items are scanned, a prompt will come up on the user's phone to enter product's expiration dates, if the user chooses to do so. Fresh produce can also be entered through the app. Since most fresh products don't have barcodes, a GUI interface will be provided to enter the respective product. We plan to keep the Raspberry Pi along with the associated components out of sight. To do this, the circuit will be installed inside the fridge. However, it must be able to withstand the temperatures of the fridge. The components will be kept in a casing that will optimize the temperature at which the unit functions at. The casing must also provide a spot for the rechargeable battery to be charged. This ensures that the consumer does not need to open the casing to charge the device. The battery being used will hold up to 12 hours of charge at a time. This is ideal because the battery does not need to be on while the consumer is sleeping, for example. The mobile app being made will be the heart of our system. From the app, the consumer will be able to view their inventory anywhere they are. The app will send push notifications to the user for things such as food recalls, upcoming expirations, and more to be determined. The app will be free to install and will be very straightforward to use.
So here is our system block diagram. We have 7 subsystems. They mainly revolve around the Raspberry Pi. And there's 3 user-initiated inputs. We have when the refrigerator door opens, a photo resistor will activate the camera modules due to the light from the fridge, and it will activate the light sensor system. From there, the camera system will activate. It will take images from the fridge contents and send them to the Raspberry Pi's onboard storage in its storage system. Let's see. The app system also has access to this onboard system as well. They can be uploaded to our wireless internet system, the domain that we have purchased. That way, through the mobile app, users will also be able to use them on the go and edit them and create their own lists. There's also 2 other user inputs. One on the touch interface that comes with the fridge upgrade system that goes on your fridge. And then obviously our mobile app that you can use on your phone. Next slide. Here's our schedule. Everything up until now, we've achieved the goal. So we have finished preliminary design. That's done. Next week, we're going to observe the 498 projects. Then over the summer, we're not going to do anything. We might if we have time, but we're probably not. We're just going to focus on next semester. Week 4, 498 begins. We'll have a more detailed design draft. We'll make revisions over week 3 and 4. Hopefully we'll have a finished detailed doc design by October week 1. We'll present that. Then we'll finalize our prototype designs. We'll begin development on it and more testing, any troubleshooting that's needed, and then we'll finish our prototype and hopefully present it all on time. Next. Our bill of materials. We have 2 Raspberry Pis, 2 soldering kits, 2 camera modules, Samsung tablet that we have on hand, domain, which is going to cost us $12 a year, refrigerator that we have, barcode scanner that we will purchase, a wireless adapter for the Raspberry Pi, rechargeable battery, and a photoresistor. And we haven't spent anything yet, the money to, but these are the costs at the moment. The next slide. And here's our design schematic. This came out better on the actual presentation on live. You can't really see what's going on. On the top left, we have 2 of the camera modules. To the right of that is our photoresistor. To the right of that is our wireless adapter. On the bottom right, we have our Raspberry Pi module. And our bottom left is the power supply. Some of our design choices, we decided that it'd be best if this mounted inside the fridge and the outside. If it were to be on the outside, we'd probably have to do some drilling to make holes to allow us to get access to the inside, and we thought for the user it'd be best we just put it inside the fridge. Because we're trying to focus on making it simple for the end user, we also made it have a rechargeable battery, so that way they can just swap it out, put a new one in, rather than hooking it up to the power from the refrigerator itself. Next slide.
So our flowchart captures the process breakdown of our device in simple steps. So starting from the bottom, start, power on. Does light sensor module detect light? No. Repeat the process. If yes, then it actually starts the process. The Raspberry Pi receives the signal from the light sensor. It initiates the camera timer in 5 seconds. Two cameras capture the fridge content simultaneously. It is then sent to the domain, and the domain application stitches the two photos together to create a singular photo that gives you the most view possible, so you can see your fridge contents and be able to shop with peace of mind. Next slide.
The potential to create a smart fridge option is within our reach. The technology has been around for years, while no commercial company is known to provide devices as we aim to do. With a cost difference of 193%, we are confident in our product in providing customer satisfaction. Our schedule has stayed on track thus far, and our budget has not been tested yet, as no parts of the system have been purchased yet. References and links for our components. Thank you very much, guys.
Any questions for Michael, Anthony, and Eric? So I have a few. I'm still a little. I don't know whether I'd want to change my or charge my battery every 12 hours. I'm wondering whether you've done any what do you call it, power budget, to see whether that that's a what 12 hours means in terms of batteries versus, I don't know, a day, a week, something like that.
So I think ideally it would be, it would go into a hibernation mode, so it wouldn't actually stay on the entire time. So that would be 12 hours continuous use, ideally. But obviously, we should do a power budget, and we'd be able to give you a concrete answer.
Okay. And the schematic you had there, you obviously clearly it was a bit hard to read. In fact, it looks better now for some reason. I'm not sure why that is. But yeah, that's the sort of thing we need. But it needs to be connected up to the Raspberry Pi, and maybe you're not going to be able to, maybe with the connections you make now is not what you eventually end up with. But a little bit more connectivity on this would be good in the final report. And then, go ahead.
The trouble I had with this was most of these components are like USB interfaces or serial interfaces. On the Pi, this only shows it's a 40-pin connector on it. It only shows that, it doesn't show any of the other connections. So I wasn't sure how to really connect them on KiCad.
Okay. Maybe we should have a chat about that during the week. But
Okay.
But I mean, the things like the connection to the photoresist is probably going to be on one of the GPIO pins, which you do have access to. I suspect the camera, I don't know, I'm not sure what the connections for the camera and between the camera and the Raspberry Pi are. Is it a USB connection? It's a serial connection, is it?
Yeah.
Yeah. So okay. Let me just take a note of that. But you should still be able to say some sort of a connection. But again, it'll depend on exactly what the component in KiCad gives you access to. You may have to modify it or find another way to document it. But it would be nice to get in a bit more detail. Okay.
Okay.
Anybody else got any questions? That's good. So thank you very much. That's good. I've as far just for everybody's benefit, you submitted drafts of the preliminary design last week. I haven't put any numbers on them because it was just a draft. It was more just so that I could give you feedback. I gave you that feedback during last week's lecture, so I'm not going to give any numerical things on the drafts that you submitted, partly because it would probably be demoralizing with the numbers if I'm grading it against the rubric, right? Because they were drafts, right? They're
redundant as well.
yeah, exactly. I mean, now that you've moved things on a little bit, it's there wasn't any point. Okay, so next up, I think we have the security group. So if you want to start sharing, whoever is making the present or sharing the presentation, there we go. Jacob is, and let's see what you got.
All right, good morning. This is our presentation for our home security drone preliminary design document. It was put together by me, Kyle Bechtold, Michael Federick, Bright Obang, and Jacob Nowak. Next slide, please. So just as an introduction, in this presentation, I'm going to be covering project summary. We're going to talk about the key objectives of this project, what our goals are. We're going to give you a hardware description. This will include any schematics that we have, our bill of materials, and our budget, which are, pretty much the same thing. We'll give a description of the software. This will include our Pseudo Code, and our flow chart with state diagrams. We'll also talk about our schedule, how that's looking, whether we're on track or not, when we expect to be done with certain things. And then finally, we'll give a conclusion. Next slide, please. So just as a project summary, the key objective of this project is to design a home security system which incorporates the use of a flying camera drone along with several infrared motion sensors. This will provide a wider scope of protection than a typical stationary camera system because these sensors will be placed around various points on the property, and they each have a range of about 22 to 23 feet. So you have a wider scope of protection with that. On terms of cost, we're looking at just under $160. This will include a pre-built drone frame, an additional Raspberry Pi in case we blow up the original one, 5 infrared motion sensors, wireless charging pads, and PETG 3D printing material. As far as our schedule goes, everything up to this point, we've been on track. We've delivered everything that we need to on time. We have some proposed summer plans, but again, as was mentioned many times, we shouldn't count on that. And it wouldn't really be anything too crucial, mostly just sharpening existing skills that we already have and maybe learning a little bit more. We aim to have our final prototype done by December of 2021. Next slide, please. So, implementation of objectives are to meet the proposed objectives for this product or this project. The finished product will utilize a camera drone and infrared motion sensors in order to catch intruders. The sensors will be able to, the drone itself is a pre-built frame that we purchased, which we will customize to include mounts for our Raspberry Pi, as well as a wireless charging pad. This wireless charging pad will charge the battery, and it will connect to a dock that we will also 3D print, and on that dock will be the other half. That will be a solar-powered charging dock, so when it's sitting outside, it's just always being charged. The infrared sensors that we are getting will be placed around the property. They all have the ability to detect motion during the night and the day, so you're covered at all times. And they all have a range of about 7 meters or 23 feet. The sensors themselves, when motion is detected, will be able to send alerts to a mobile application that we will code. This ensures the system is convenient as most people nowadays always have their cell phone on them. So the app will be coded using Python programming because it is the language we are most familiar with. And the app itself will act as a main control hub for the entire system. This means that within the app, the user will be able to toggle the system on or off, take control of the drone when it's in flight. You'll have an option to be able to directly send, directly contact the authorities, and you'll also be able to access the media recordings taken by the drone, captured by the drone camera. These recordings will be kept either in a storage database or on an external hard drive. That remains to be determined as we develop further. Next slide, please.
Moving on, we are on the deployment diagram. Between our diagram, we have 3 devices: the cell phone, drone, and motion sensors, which are all via Wi-Fi working-wise. If we begin with the cell phone, we will run off the application, which allows the user to contact authorities, either trigger their alarm or control either their settings on their drone, such as range-wise, things like that, or create an account with us to be able to save your data files after your recordings are made. Which then you could either contact via Wi-Fi to your drone, which allows you to then patrol areas that are basically are not on the or past motion sensors, which you could then take control of your flight, or record the media, which allows you to then save the files after in our bay. As well, off the cell phone, we could then control the motion sensors also via Wi-Fi, because those are the items that are detecting motion, which signal after to our drone and then back to our cell phone if we are needed to contact the authorities, etc., trigger the alarm.
So for this project, we're gonna need a Raspberry Pi, a drone, sensors, and then solar panel charging station. So for the Raspberry Pi, it's a single board computer with a processor ARM11 video core. It has a micro SD storage interface and comes with a 2.04 USB port. It also has a universal asynchronous receiver transmitter, which is UART, and an SPI bus with 2 chip select, which can be used to connect a wide variety of peripherals, displays, and network controllers. It has a general purpose input or output with 40 pins. There's also a dedicated TSI2, which is the camera serial interface, and comes with a display port, DSI display port. So for the drone, we got a pre-built frame from Amazon, which is the Gilo Baby STEM RC drone, and it has a dimension of 8 by 8 by 5 centimeters and weighs about 386 grams. It also has a 360-degree or angle flexible movement function, which ranging from upward to downward movement, forward and backward movement, left and right rotation, left and right drifting, up and down, and stunt flips. It also comes with one main body and a main PCB, and also comes with one USB charger. Comes with 4 motor and a main body head, and comes with 8 blades and 1 drone battery. So for the sensors, we got that from Amazon as well. We got 4 of them, and they weigh about 0.1 ounce and detects motion up to 7 meters away or 23 feet. And it operates at a voltage range of 4.5 to 20 volts. It can turn on devices by detected motion. And move on to the solar panel, which is also the charging station. So the charging station will be made of a wireless solar charger consisting of receiver and transmitter. The charging module will be it's an 80 millimeter DC remote module. It will have a transmitting voltage of 24 volt. It will have a transmitting core of inner diameter of 70 millimeters and outer diameter of 88 millimeters. Next slide. So we move on to the bill of materials. So for the bill of materials, can you move down to the slide with the bill of materials? Yeah, thanks. So we have the part name, the Raspberry Pi 3B Plus, and the part number, the per unit, and the unit cost. So for all the parts that we're gonna be needing, that they're listed over there, and the total cost will be an estimation of $157.99. And then we have the bill of materials too. I mean the power budget. Yeah, thanks. So for the power budget, which is almost the same as the bill of material, comes with the Raspberry Pi, the drone charging station, and the sensors, and gives us the arms voltages and power that we need for that. And the total power will be around 26.6 watts. Next slide.
So this is our design schematic of our drone. For the first item, the mounting holes, there will be 4 mounting holes that will mount the Raspberry Pi to the drone. The second item is the Raspberry Pi 3, which will be used to allow the user to configure the drone through use of an app. The third item is the battery pack. The drone comes with a rechargeable battery pack that would accommodate the power needs of the Raspberry Pi, the motor, and the drone. The next item is the camera. A camera will be attached to the Raspberry Pi through a USB port to capture and record media. The last item is a wireless charging module receiver. This would be attached to the bottom of the drone, which will charge the rechargeable batteries. So this is basically the sensor schematic. These sensors will be attached throughout the background of a house, and will send feedback to the app once detection is sensed.
All right, coming up, we have software description, which I will be talking about our pseudocode, our flowchart, and our state diagram. Beginning off with our pseudocode, our code would basically start off as starting the whole system, which will then after ask the user to install an application. Once the user launches the application, it will ask the user to connect to the drone via the application. And then the drone will stay idle throughout the whole life course most of the time. When then motion is detected, user enables the drone to be able to follow where the sensors detect it. If motion is then detected, the drone is launched from the app, and user can either fly the drone, or the drone itself will track the movement, which will then record the media, notify the user, and if the user has any input, then they could either set their alarm off or contact the authorities. But if not, then the drone will fly back to base station and stay. Moving on to our flow chart, starts and acts onto then the power on of the system and see if the sensors detect any motion. If there is not any detection, then the drone remains idle and awaits more detection. If there is detection, then an alert will be sent to the user to see if media wants to be recorded. The user takes its action, its wants, and the decision is made, and it goes back to seeing until the next detection is made. As for the state diagram, we start the system again. Sensors are enabled. The drone stays idle. When the drone then detects motion, we then send an alert and record the media, and the drone again waits for the user's instructions. After each action, if the user decides to ignore the alert and it's a false alarm, it goes back to its drone idle state. If the user takes control of the drone or wants access to where the motion is, and if the detection is not a threat, it goes as well back to idle state. If it is a threat, it will contact the authorities, siren the alarm, and go back to its idle state as well.
So this is our schedule, our proposed schedule so far. Everything we've done up to this point has been on track and delivered on time. It's mostly been dealing with our preliminary design up to this point. But as we progress further, we're going to have summer vacation coming up next. And as I mentioned before, we're not really planning on doing too much development. If anything, we would focus more on just honing our existing skills, so that way when we come back for the fall semester, where we will begin our detailed design, followed by prototyping, we'll be more prepared to do so. Next slide, please. This here is just a Gantt chart that shows the same thing with the schedule, gives you a better visual of the timeline of everything. Next slide. So, in conclusion, our home security system will provide an alternative solution to protecting your property. The mobility of the drone combined with the range of the motion sensors allows for a wider area of coverage than traditional static mounted cameras. The total cost of this project currently sits at approximately $160, but that is subject to change as we progress with development. We're aiming to have our final prototype out and completed, ready for presentation by December of 2021. And for this project, we will need to be utilizing our team skills such as Python programming, app development, electronics, and networking. Next slide. That concludes our presentation. Thank you all for listening.
Okay, very good. Thank
Okay,
you.
good job.
Thank you for the presentation. Does anybody have any questions for the home security team? So I think you were actually pretty good. I liked some of the extra stuff in there. The main comment I have is some of the earlier slides were a little bit too text heavy. I've been watching a lot of presentations in the last couple of weeks, and one thing I'd notice is people tend to be a little heavy on the text. I sort of had the same comment for the smart fridge update. I had more I think there was less of an issue than for this security team. Comment on BOM, bill of materials versus budget, right? So the bill of materials, including the cost of the bill of materials, is just the stuff that goes into the product. The budget includes that, but it also includes maybe what, if you were doing this in an engineering company, what they would call the NRE cost, the non-recurring engineering costs. And that can be anything from buying tools that you're potentially going to be using for more than just one project. That can be training. That can be all sorts of other stuff that the project needs to work, but isn't a cost, a per item cost of the thing that you're building. Okay. So the other piece was the feedback on text. I think it's possible to get more diagrams or more pictures. You did actually have some, and I would have in this sort of a presentation, I would try and include maybe a few more. I liked the use of Microsoft Project. Thank you for doing that. That was really good. I had the question I had, and this is a long-winded way of getting there. You're going to develop an app. Have you decided how you're going to do that? What whether it's iOS or Android or both, or how you intend to do that?
That kind of is up in the air right now. None of us really have too much experience dealing with app development, so that's something that we're actively working on. Most likely it will be on Android, just because it's a little more accessible. I think, there's a lot more open source stuff, and you're not constricted with Apple's proprietary stuff. So most likely Android, but as we progress further, we'll have a more clear-cut answer. Okay,
just if you do want to do both, then there's the possibility of using one of several cross-platform development tools. There's what's it called, React Native, which lets you program in JavaScript and can be deployed on iOS or Android. There's Xamarin, which is a Microsoft product that lets you program in C# and again lets you deploy on either iOS and Android. The one catch with iOS, as you're aware, is that you need a Mac development environment in order to build for iOS, but Android you can build on anything pretty much. I think they have development tools Google has development tools for Windows, Mac, and I think even Linux. It'll run on Linux, the Android Development Studio.
That's actually really helpful. Thank you.
That's okay.
Because we were thinking about studying harder for how to code out the app over the summer. That was our plan for our summer, so that actually could help a lot more.
Yeah, I mean, feel free to ping me over the summer. I do a lot of I teach a mobile application development course at Fairfield, and I use Xamarin. The nice thing about Xamarin is it's sort of a development studio environment, and it runs pretty much the same on either Windows or Mac. And the other nice thing about Xamarin is you can also do the server-side code in the same environment. So if you need to run something on a server somewhere, it's you can have the app, either Android or iOS or both, and you can have the server-side component sitting in the same solution file, which is kind of nice. Anyway, but talk to me about that if you could be bothered over the summer.
Sounds great.
Okay. So let's so let's go with the parking group. Whoever's the presenter, can you please start sharing your screen and we'll get the third presentation going.
Alright. Should be able to. Cool. Do something real before I start. Alright. Can everyone see that alright?
Yeah, I can see it fine.
Alright, cool. Alrighty. So, for our system, we wanted to make, obviously, an automated parking system. And by doing this, we would remove the need for searching for parking spaces by simply going up, in a parking garage, by going through the entire garage, seeing where a parking spot is, and hopefully getting there before anyone else does. By using this application, we can give everyone the opportunity to find a parking space using the app and not just randomly finding them and kind of first come first serve basis. The app can organize where everyone's going, and you can see before you get into the parking garage where there are open parking spaces and where there are not. And that could save up to $73 billion overall over the course of a year, just from searching for parking spaces alone. For everyone, but it could really give us the opportunity to do other things in that time. We could get out earlier, get to meetings on time, stuff like that. So, for our use case diagram, you can actually see my mouse. For our use case diagram, we wanted to make it, obviously, a system like this needs to be durable and as simple as possible. So, the main actors in this are simply the driver, who's finding the parking spaces, the parking application itself, which is kind of directing everything in the background, or for everyone to see through the application, but it's directing where everyone should go. And then the parking lot manager, which is the devices. So our design calls for determining whether or not a parking space is available. Then when it occupies that space, there's going to be IR sensors in the parking space itself that will say, oh, this parking space is now occupied, we cannot use this space. And then the IR sensors talk to the Arduino system, and then the Arduino tells the software application that the spot is full. And then the software application goes back to the user, says this spot is full, and then it determines where there is another spot available. And then when the vehicle or the user leaves the parking space, the IR sensor will no longer detect it, and it'll do the same thing, but telling the application that it's no longer detecting a device, or detecting a vehicle, and then that space is now open. Alright, Fahim?
Yeah. Okay, I'm gonna explain the design parts. And this is the first time I use KiCad, and I try to make the component more readable, but there is no option in KiCad to make the component itself readable. The only way, if Kyle can zoom in, maybe you're able to read all, here you go. So that's how I designed the circuit. There is Arduino Uno R3 in the middle, to the left side, that's the LCD display, and is required to have 3 resistors, 1000 kilo ohms each one. And to the right side, and the top one is an IR sensor, and the bottom one is IR sensor, and the middle one is the servo motor. How this circuit is gonna functional and work is the Arduino gonna have software, the code. We're gonna write the code and apply this application code to the Arduino. So when there is a subject, a car coming to the first sensor in the bottom, Arduino will work two-way. First send it, alert to the servo motor to open the gate. And then in the same time, send an alert to the display telling there is a car getting in, and it will display the parking empty space. If we're gonna make about 5 spaces in our design, so it's gonna say 4 left available, 1 occupied. While the car enter the parking garage, the sensor will be active. It will stay it is. If they are leaving the parking garage, the sensor in the tab, it will send an alert to the Arduino. Same thing, Arduino work with two-way. Alert to the servo motor to open the gate. Send the alert to the display. There is more space available. And I try to do my best. Like I said, this is the first time using KiCad, and I try to wire it and make it very, readable and understandable. Next slide. And our budget has Arduino Uno R3, Raspberry Pi, those we got them for free, servo motor, IR sensors, which 2 of them, LCD display, and 3D printer, which bring the total to $208.96. Maybe this subject will change to the subject if we go back to school in the fall semester and we're able to use the 3D printer, school printer, or use of our other groups might is lower the cost. And next slide. Oh. Okay. Kyle, I think is your turn.
Yeah, sorry, my mic didn't want to unmute. For our design proposal, our schedule consists of, first off, our summer break. I set it so that we start again back in the fall semester, so that way we don't have conflicting schedules with anything in the summer. For our design documents, everything will take, actually the entire thing will take about a week per section. Our plan is to successfully be able to have a pre-prototype, so like some kind of material documentation, just like a material mock-up of it, that will be able to implement our aforementioned design. And then we want to troubleshoot that as much as possible. That way, we know what's going to go wrong for our actual prototype, and then try and basically beat the thing up until we work out all the kinks in the device, and then we'll create our, we'll document all of that, and then create an actual prototype. And that prototype will be used in our final presentation.
All right. Throughout this project, it has come, to light that this could be very beneficial to people that, live in very busy communities where they actually struggle with finding parking spaces constantly. The feasibility of this project is fair, as the budget only comes down to around $208, including the 3D printer. But as Fahim said, if we do get access to the 3D printers in the fall, the budget only comes down to around $40, give or take. The implementation plan that was proposed in the schedule is, on time as we are doing it. And it's definitely what we need to complete each week to finish the project by December. This project, would be able to be implemented after the initial prototype is done. Basically, any parking garage that meets the requirements or, needs it. And the overall need for this project and system is basically to the struggle that many people face when entering a parking garage and finding an open parking space.
All right, and that's everything. That's my
Thank you.
background.
Ooh, paintball. Okay.
Yeah.
Love the paintball background.
So I got a few questions, and I probably should have said something for the other two groups as well, but it only really came to mind while I was watching your presentation. Be prepared to spend time on the sensor. I suspect it's less of an issue in the other two projects, but the smart fridge upgrade, making sure you reliably detect when the door is opening is I don't know how big a problem it'll be, but it's likely to be an issue. And similarly, the security, making sure that you get appropriate motion sensing signals. Here, I think it's a little more of a problem with the parking, because you're going to have to sense different sized objects. And okay, they're big objects, but I think do you have any sense of what how accurate your suggested sensor will be for detecting cars?
Not currently. I imagine it's a tire. The only issue would be is if like someone parked forward or back. So that's the only issue I could see with it so far, is if like someone didn't park all the way up to the sensor.
And the other thing is, I didn't quite, maybe I missed it. Is it, how many sensors in a parking garage would you have?
So per parking space, there's 2 sensors.
Okay, per parking space. Okay. And then does it matter what the layout of the garage is? Do you need a map of the garage in order for your system to work?
Theoretically, yeah. Yep.
Yeah, okay. Just on some of these, or some systems that I've looked at, and I don't know how well they worked, but one of the things they did was they didn't actually measure on a per parking bay basis or parking space basis. They measured, and this was for larger multi-level lots, they only measured the number of cars entering the level and the number of cars leaving the level, right? So that way they don't have to measure as much. But again, as I said, I don't know how accurate that ends up being overall. I had a question about, I think I saw on your schematic that one of the processors, the reset bar pin was connected to ground. Is that true? I don't know whether you want to do that.
I don't see that schematic in front of me. No, the reset is gonna be positive.
Right. So yeah.
And the things I want to mention about the sensors, I'm trying, if we eliminate those sensors, without installing sensors in each spot, we will use only 2 sensors for entering and exiting the park. So that's make us able to create a code for the application. If we added too much sensors for each spot, that's what the plane we're going to do. But we're gonna challenge with the code. The code maybe is gonna be a little tough and difficult with those too many sensors.
Right. So I mean, I either way, I think having sensors per parking space is gets you more accuracy, right? With the only entering and leaving, you only know how many are supposed to be in there. You don't get a sense of where they are inside, so it's harder to tell the drivers where the parking spots are. But if you know the actual locations on a per bay basis, then you can do the yeah. I don't think I have much else. So thank you all three teams for presenting. That was good. Let me just get my screen back if I can figure out where everything's gone and where I can move everything to. There we go. That one can go there. And let me go to that one. And the projector output, but let me put my mini-me back. There we go. And I've moved my, there we go, camera around. Okay, so we've done the 3 presentations. 2 things we've got to do between now and summer. One of them is to, well, 3 things. One of them is to upload your presentations into Blackboard. Please do that. The second for the course is to upload your preliminary design document, and I would suggest you upload it soon and get some feedback from me. I would like you the final version done by Friday next week, and I've set it to 11:59 p.m. on Friday next week. So because we're not meeting next week except for the 498 presentations, which is the third thing to remind you about. And I sent an update on my calendar invitation. I added the link to Professor Braverman's Discord server. And that's it. I think that's about it. If you haven't already, please give feedback on the course evaluations. I know it's painful and you get them every semester, but I don't think I'm quite up at the green level yet. So in fact, let's just have a quick look and see where I am at. Where are we? My course evaluations. Yeah, so for 497 I've got 4 and it's still yellow. So please get in there. Thank you to the 4 people who have already submitted. That's good to see. Yes, I would like to get a few more. Any questions?
I had a quick question about the journals.
Yeah.
So we're supposed to be doing them weekly before Friday. So I've been doing them in the same length that is attached, but the dates haven't changed. So I don't know if I'm doing it correctly.
I am seeing them coming in. So yes, just so the date on the journal is just the date I posted, right?
Gotcha.
And
all right.
The Google form timestamps everything. So that actually,
right.
If everybody could get in there and do your one for this week again, that would be good. What I'll do is once I see a few more come in for this week, I'll share with everybody individually where you are relative to everybody else, but I won't show. I'm not using that this semester. Next semester I'll be using it to just to track how everybody is going individually, because next semester just about everything is on a per group basis rather than on an individual basis. And I would like to be able to differentiate, particularly not so much on the lower end. I want to celebrate the people who go above and beyond rather than the other way. So it would be nice to be able to recognise when your group members go above and beyond. Okay, so let's leave it there for this week. Thank you very much. Thank you for a good semester. Next semester we should be back in person, so that'll be interesting. I'm hoping we're going to be in the new building, but I'm not sure it's quite going to be ready, but we'll see how we go. I'm currently scheduled in 157 again, so I don't know what that means. It might just be that they don't want to swap over to the new building until they have a new building completely open, so we'll see. Thanks for your time this week. Let's leave it there.
Thanks,
Thank you,
Professor.
Professor.
Have a good one, Professor.
Yeah, have a good weekend, everyone.